Hi, my name is Yannick Inkicic, and this is my intermediate milestone number 2 for my development project for EdTech fall 2018. I'm going to provide a link to my video for my previous intermediate milestone, and I'm not going to repeat everything I said there, but at a very high level, I'm developing a type of intelligent tutoring system called a cognitive assistant, which will essentially allow me or the user to offload some of their cognitive, essentially load, onto this assistant. So say they're performing some sort of application on their computer or performing some sort of effort, some sort of work, whatever they're doing, my computer should be able to essentially just look at the pixels on my screen, identify what I'm doing, and then support me in doing that in some way, whether it's doing it for me or enhance my capabilities in solving the problem in some way, whatever. So in the previous intermediate milestone, I showed off a few things. I'll bring up my task list. So last time I worked on the initial screen grabbing, which essentially just looks at pixels and is able to pass those essentially as screenshots directly to my agent. And I did that in a number of ways, including just passing in what the window name is, or the process ID, or just capturing a portion of the screen or the entire screen. I also added mouse and keyboard interactions, as well as showed off displaying info back on screen. So, if something's happening in this particular area, how can I bring the user's attention to that, whether it's by circling it or adding text or whatever. Since then, I've mostly been working on hooking up a pre-trained deep neural network module to my assistant with a focus on object detection initially. And I'm going to show that off in action today. So, right now, essentially what I'm doing is passing in this entire left side of my screen and having my code just run that and tell me what's happening there. So I'm going to launch now. It's going to display it back on the right side. You can see here on this still image, it's identifying this baseball player as a person, as well as this one right here. If we play that, that it is pretty well at identifying this is a person, this is a person, this is a person. Back here in the background, you can see that this model struggles, and that's just an issue with object detection in general. But as a proof of concept, sort of, showing the capabilities of this does pretty well here. If we switch to just some still pictures, so here we have some families in these Google images. If we bring that up, we can see it does pretty well at identifying who all the people in this image are. Same here, and it does this live just by looking at the pixels on the screen on the left and immediately knowing that it needs to be doing object detection of some sort. Here we have cars. Just another example, doing pretty well there. And then motorcycles, this one's kind of cool. Here you can see that it sees both the motorcycle and the car in the background. This one's even better. You have a motorcycle with a person on it. It's very confident in identifying both. Same here. But you get the idea. So I've got this really cool object detection module hooked up. One nice thing is that I went for a single shot detector MobileNet, with the reasoning that it's a little worse in terms of object detection abilities, but it is very fast. So one very important part of this is that it has to be real time. So this object detection is happening just based off what the pixels are on screen, and the inference component has to happen in real time without much lag. So my sort of cutoff is to get at least 5 frames per second of object detection. So my actual pixel grabbing from the previous milestone, I was able to grab the screen at roughly 120 FPS. I actually had some issues with this while adding the object detection, and that I managed to completely break my previous code. So I had to go back and completely re-engineer that. But it's actually just as fast now, so I'm pretty happy. And it's more capable in the sense that it's much more flexible in terms of what I'm capturing. So I can pass in any number of directives to tell my agent what to capture, what to look at, and that can be made more efficient. So say in this case, for example, I only expect things to happen on one half of the screen, right? I don't need to be capturing the whole screen. I only need to look here. And you can see that this is working on whatever pops up. One of the issues, and you can see that here actually, is that, well, this top left image is being highlighted correctly as a motorcycle. It's struggling with some of these other ones, and that's just because the pictures are too small. So the model, and this is an issue with this sort of model, period, is just that for speed and efficiency purposes, they need what they're identifying to be large enough. It struggles with small objects. So here, bigger, no problem, but small, it thinks this is a car, which clearly it's not. And in a larger picture, it's able to identify that correctly. So there we are. Object detection works wonderfully. The next step that I have here is to build out the initial domain knowledge proof of concept. Unfortunately, I'm not quite there yet. The idea being that this deep neural network detection module obviously isn't relevant to all tasks. It's only sometimes that this might be relevant to, say, when I'm watching a video of something and I want to know what's on screen in a sort of surveillance capability, or just looking at a picture and be like, hey, tell me what is on my screen, what sort of image is this, right? These are all people. Cool, got that. But other times maybe I'm playing a game and I need help solving it. So there, I'm going to pause this. One example that I want to do is create a Minesweeper module, which essentially is able to identify when Minesweeper of some sort is running, and then have the domain knowledge to solve it, essentially, and then provide that sort of help if I get stuck, or even go as far as solving it, which it can do because I have that mouse and keyboard interaction feature already added in. So a little behind right now where I wanted to be, just because I struggled with this deep neural network object detection aspect. It just took more time building that out, especially when I had to go back and fix my screen capturing. But hopefully, this won't take too long. Worst case, I'll have to dial back this proof of concept to just a very simple example of the capabilities. But I have that scheduled for the next 3 weeks or so I have plenty of time before the paper's due to actually get this done. Thank you for listening.